All right. Today we are finding limits again. We're going to start off here looking at what we did yesterday, looking at them with a table. We are going to do lots of multiple choice questions now that we're into calculus. I want you to make sure that as you work through these, you think them through. Don't just pick a letter. That's not going to help you. All right. So in Bell work here, they love these questions on the AP exam. They like to throw in the F only, G only, H only, etc. This table gives the values of three functions, f, g, and h, near x equals 0, based on the values given. For which function does it appear that the limit as x approaches 0, so the limit as x approaches 0 of whatever function is given, f, g, or h, is going to be equal to 2. That's what we're trying to figure out. Which of those is going to have a limit at 2, or a limit equal to 2? Show me with your fingers. What did you pick? 1 for A, 2 for B, 3 for C, 4 for D, 5 for E. Show me a number. 1s, 4s, and 5s. 1s, 4s, and 5s. I think we're kind of the setup. So, everyone in their choices, 1, 4, and 5, you all agreed that F is going to have a limit of 2. Let's see if that's true. Here is F right here. As I work this way towards 0 and this way towards 0, am I approaching the same number? What number am I approaching? 2. Lovely. Since I'm approaching 2 from both sides, that one works. Letter A, if I did f of x, is going to have a limit equal to 2. So it is not B or C because f is 2. The limit at 0 of f is 2. Good on the first one. Let's do E next. So the difference here is we're saying that G does not work. Let's see if that's true. So if I approach this side, I got 1, 1, 1, 1, 1. On this side, I got 2, 2, 2. Oh, but at 0, the limit is 2. So the limit's 2, right? Do I care what happens at 0? No, we don't care what happens at 0. All I care about is what's happening around 0. It's 1, 1, 1, 1, 1. It's 2, 2, 2, 2, 2. Am I approaching the same number? No, those are not the same number. One is 1, the other one's 2. So G is not going to have a limit equal to 2. The limit, what's the limit going to be for that one? That one's D and E. Okay, G of x is going to be D and E because I have two separate numbers that I'm approaching from the left and from the right. Last one. So now we're making, so it's not E. We're making the decision. Is it A or is it D? For H, I got 1.971, 1.988, 1.997. And we're going this way. Oh, but it's undefined. So since it's undefined, then the limit is D and E, correct? No. Do we care what happens at 2 or at 0? No, this doesn't matter. All we need to do is look at from the left and the right. From the left and the right, am I approaching the same number? Yeah. And what number am I approaching? 2, which is the whole goal. Am I approaching 2? Yes, I am. The answer is going to be D. Understanding what limits are and how we find them looking at tables, an important concept. All right, yesterday when we did notes, we talked about limits graphically and with a table or numerically. Today we're going to talk about them algebraically. And today's lesson in itself is super easy. Okay, the concept is not difficult at all. You just got to act it. You just got to work your way through it. And there's a lot of different mistakes that you could make, but if you can do basic math, you're going to be fine. This is Algebra 2 level math today. All right. We learned yesterday, and you did a little bit in your homework last night, that you can find a limit simply by taking a number and plugging it in. If you can plug in the x value, it can tell you the limit. So, for example, if I take the number 4 and I plug it in here, 4 squared plus 2, what is 4 squared plus 2 going to get me? That is the limit. The limit at x approaching 4 is going to be 18. I am now done with that problem. If you can just do direct substitution, you're going to be perfectly fine. The one thing you got to pay attention today is this, and we just, a reminder. If you have 0 on top, but a number on bottom, like 0 over 1, that right there is 0. If you have the other version, so you have a number on top with 0 on bottom, that is D and E. Okay, that does not exist. That is undefined. If we have 0 over 0, we got to do something else. Okay, and we'll talk about that today. Try letter B and C with your neighbor real quick. Think your way through it. With your fingers, what did you find on letter B? What is the limit? Yeah, it's just 3. We're taking this. Oh, we can do direct substitution. What am I going to plug 43 in for? Nothing. There's nothing there. Show me with your arm, what does 3 look like as a graph? 3 as a graph is 1, 2, 3. It is a horizontal line. So what is the y value going to be at 43? Still 3. That's why the limit's 3. Don't let that one be weird to you. It's just 3. What about C? What do you think the limit is as x approaches 10? Yeah. Boom. I plug in 10. I get 10. That's not too bad. Try the next 3. Try E. Try the next 3. D, E, and F. Go. So show me with your fingers. What'd you get here on D? On D, what'd you get? All you got to do is take -3. You got to plug it into 2 different spots. Who cares? We can do that. -3 times -3 plus 1. That's -3 times -2. That's 6. Good. Letter E. Show me with your fingers. What'd you get on E? You just get 3. We take 2. We plug it in. You take 2. You plug it in on top. You get 12. You take 2. You plug it on bottom. You get 4. 12 divided by 4. That's 3. Show me on F. What'd you get on F? All right. So some of you got some good answers. I'm glad no one is telling me just 0. Okay. Because the answer is not 0. We take 1. We plug it in. You take 1. You plug it in. You get 0 on top. You get 0 on bottom because or you get this 1 minus 1 and then 1 squared minus 1. That is 0 over 0. What is 0 over 0? Is that 0 or is that undefined? The answer is neither. This right here, when we get 0 over 0, this is called indeterminate form. Indeterminate form, meaning you cannot determine what's happening. If we get 0 over 0, anytime we do a limit problem, the last lesson of the year this year, we're going to talk about this again. But we're going to have to do some more work, okay? There's going to be something more that we have to do if we're in an indeterminate form because we don't know what it is yet. It could be 0, it could be undefined, it could be something else. We just don't know. What is happening on your graph if you get 0 over 0? This is a hole. This is a hole in a graph. Can you find a limit if there's a hole? The answer is yes. Yes, you can. Okay, let's look at this thing. I got it somewhere. Where are you, Desmos? Nope. Nope. All right, we'll just start from scratch. All right, Desmos. We're graphing this thing. We have x minus 1 on top, and on bottom it's x squared minus 1. We get this graph right here. Okay, we got 0 over 0. Understand why? When I go right here on my graph, I'm getting closer and closer to 1. See what happens there at 1? It's undefined because there's a hole. But I don't care what happens at 1. I care what happens around 1. So watch as I approach it from the left-hand side. What's my y value getting closer and closer to? What? What's my y value getting closer and closer to? A half, 0.518, yeah. Then we approach from this side. What's my y value getting closer and closer to? A half. The answer to this question is 1/2. Okay, we haven't found that yet, but we got to eventually. The answer is 1/2. How do we do that? Well, we did this back a while ago. It's been a minute, but we've done it. What we're going to do, if you get 0 over 0, we have to do more. And our more for today is we are going to factor. Okay, on top, it's x minus 1. What can I do on bottom? How could I factor that? X minus 1, x plus 1. We're going to find the limit as x approaches 1 of this guy right here. If we factored correctly, if we get 0 over 0, when we factor it, we should be able to cancel something out. Can we cancel here? We've got an x minus 1 on top and x minus 1 on bottom. So we get 0 over 0. We factored, then we're going to cancel, and then we are going to plug back in. This is the number one mistake made on this problem. When I plug in 1, what is my answer going to be? 1/2. Because where is that 2? It's on bottom. I'm taking 1 plus 1. That is 2 on bottom. It is 1/2 on top. There's still a numerator of 1. When those things cancel, it gets you 1. Be careful there. That's the number one mistake that will be made on our next quiz. Questions on that guy? Kind of makes sense? So if you get 0 over 0, factor, cancel, plug back in. Try those next 3 with your neighbor. See what you can do. Let's see what we can do. 'Letter G. Show me with your fingers. What you get on? I don't care what happens at 2. At 2 doesn't matter. What I really care about is what happens to the left and the right. What is the answer going to be here as I approach 2 from the left and the right? What am I going to get? D and E. They're not approaching the same number. Okay, so I already know what the answer is going to be. But in order to decide what's happening, I need to look at both sides. And because they share this value, both equations, yeah, they're both not equal to 2, but I don't really care equal to 2. I'm going to look at the left and the right. Normally this doesn't matter because it's not going to be at the break. But if it's at the break line like this, we've got to look at both. Half of your AP test is free response. This would be a question they would put in free response. And this is how you're going to have to write it. You're going to write the limit as x approaches 2 with the little left-hand sign, the little minus sign of f of x. And our job is to decide, and I kind of made this symbol up, but I think it's helpful. Is it equal to, it's a question, to the limit as x approaches 2 from the right-hand side of f of x? That's what we need to decide. That's how we decide if there's a limit. If they're both equal to each other, then we know what that limit is. If they're not equal to each other, then the limit's going to be d and e. Which equation am I going to plug into if I want to find the limit as x approaches 2 from the left? The top one, the x squared equation. So all you got to do is plug in 2 squared. I get 4. How am I going to find the limit as x approaches 2 from the right? Bottom equation. If I plug 2 in here, so it's going to be 2 times 2 minus 2. 4 minus 2 would get me 2. Is 4 equal to 2? No. Since the left and the right-hand side get me 2 different numbers, the limit is going to be d and e. Kind of makes sense on how we're making that decision. All right, let's go to the back side. So on the back side, I didn't give you a graph. I just gave you some equations. Try number 4 with your neighbor real quick. See what you get. Show me your answer once you find it. Here we go. We are finding the limit as x approaches negative 3. If that negative 3 just was a regular equation, we're good. We just plug it in. But because it's happening at a break line, this equation is going to tell me what's happening to the left. This equation is what's going to tell me what's happening on the right. I need to look at both equations. So I need to find the limit as x approaches negative 3 from the left of f of x, and I need to decide, is that equal to the limit as x approaches negative 3 from the right of f of x? To do it from the left, all we're doing is plugging into this equation. So 1/3 times negative 3 cubed plus 3. Negative 3 cubed is negative 27. Times 1/3 is negative 9. Plus 3 is negative 6. We go to this one. Negative 9, we're plugging into this one. X is greater than negative 3. So negative 9 plus absolute value of negative 3. So that's negative 9 plus 3. That gets me negative 6. Are they equal? Yeah, if they're equal, it's whatever the value is. So in this case, the answer is negative 6. What happens if they weren't equal? What would our answer be? D and E. It would be D and E. Let's go to the next one. Letter B. Find the limit as x approaches 0. Just talk with your neighbor for a second. Think about which equation are you going to plug into. What do we think? Which equation are we going to plug into? Top or bottom? Or both? The answer is just the top. Anybody want to have a good reason as to why it's just the top? Henry, what do you think? Perfect answer. The top is both sides. The bottom tells me what is happening at 0. Do I care what's happening at 0 when I find a limit? No, this doesn't matter. Okay? Understand what this is a graph of. Here's my graph. Okay? 3x squared plus 2x over x. That is everywhere where x isn't 0. The only other thing it tells me, the whole x is equal to 4, all that would give me is an ordered pair. It would tell me the ordered pair 0, 4. That is all this graph would be. Which thing do I care about? Do I care about the 0, 4, or do I care about the graph? The graph. The reason why it's not 0 is because it's undefined at 0. Great. It doesn't matter anyways. So all I have to do is just plug in to this equation. So if I take 0 and plug it into this equation, I would get, find the limit as x approaches 0 of this f of x equation. So we would get 3 times 0 squared plus 2 times 0 all over 0. Oh no, I get 0 over 0. What does that mean I need to do? Factor. What can I factor on top of this thing? Take out an x, finish it. We factor on top. Since both things have an x, we take an x out. Then I'm left with 3x plus 2 left over. On bottom, I just have an x. Oh, I got 0 over 0, so something should cancel. I can cancel the x's on both. Once I've canceled the x's on both, all I got to do is take 0 and plug it in. That is 3 times 0 plus 2. My answer is just 2. Make sense on how to find those limits? This next one's kind of strange, and don't let the strangeness of this overwhelm you. We're going to do this later on, okay? I'm just going to kind of help guide you as we do it. Find the limit as h approaches 0, okay? You don't have to write this down. I'm just going to show you. We find limits. How do we find a limit? What do we need to do? Plug it in. If I take 0 and plug it in, you don't need to really write it, but I'll show it to you. 4x squared minus 3x, because that h would go away, plus 2 minus 4x squared plus 3x minus 2 all over 0. I just plugged in 0. I got to get an answer. What could I do from here? Combine like terms. I've got a 4x squared and a negative 4x squared. What's going to happen with those two things? They cancel. They get me 0. What else could I do? Negative 3x and a positive 3x. Those two things are going to cancel. Anything else? Oh, no. 2 and a negative 2. Those two guys are going to cancel. So what did I end up getting? What do we have to do if we get 0 over 0? Factor, cancel, plug back in. So right now, well, that's not it. We can't be done. We need to factor. Now, this one's a little bit different factor, right? This is not one that you just look at and you're like, oh, yeah, I know how to factor that. It's going to involve a little bit of work, and we're going to do this a ton here in about 3 weeks, okay? But for right now, we're just going to look at it. So instead of straight factoring to start, we are going to simplify a little bit first to make it factorable, all right? What can I do with that thing right there? I have to square it. How am I going to square it? FOIL, good. That is x plus h times x plus h. If you don't know what that is, I strongly suggest you just memorizing it because it'll make your life a lot easier. But if I were to FOIL that, it would get me x squared plus xh and then plus another xh. So it would get me 2xh plus h squared. Go ahead and write this part down. Sorry, I didn't tell you to start writing again. So we got that. This 4 is out in front. Minus 3x minus 3h plus 2 minus 4x squared plus 3x minus 2. And that is all over h. We didn't plug in 0 yet. We've got to cancel before we plug back in 0. It didn't work, so we simplified here. We still got to do a little more simplifying. See if you and your neighbor can finish that the rest of the way. Kind of an annoying problem. Again, we'll do this again more later on. Don't get too frustrated by it right now. I distributed that 4 into this thing as well. So I got this thing in blue. Okay, once I've done that, Matthew, what can I get rid of here? What can I do when I combine like terms? 4x squared and a negative 4x squared. Those two things are going to cancel. What else? Evelyn, what else can I get rid of? The 3x and a negative 3x. Those two things are going to cancel. Sadie, what else? The 2's. She's got a positive 2 and a negative 2. Those things are going to cancel. Once we've canceled that, that's everything that can cancel. What do you notice about everything left on top? It all has an H. So we still are following our same rules. We're going to factor, cancel, plug back in. How can I factor the top? Take an H out. So now I'm going to be left with this. That is what I get. I just took an H out of each one of those parts and wrote it out in front. I'm still finding the limit as H approaches 0. What now? I factored. Now I'm going to cancel. The H's are going to cancel, and then I'm going to plug it back in. I'm going to take that 0 and plug it in right there. So I'm left with this strange answer, at least for now, of 8x minus 3. That is the answer for that question. Again, we'll do it more later on. If that's confusing to you, I'm not super concerned about it yet. Okay, but that's what eventually we're going to be able to do. Kind of makes sense on that one? Again, direct substitution rules still apply. We had to factor, cancel, plug back in. We just had to do a little work first before we factor. All right, last two things of the day. A graph we need to know. This is a graph you need to understand. We did it a little bit yesterday. We're going to do it again here today. Okay, if we want to find the limit as x approaches 3 of this g of x equation, we need to understand what this graph looks like. Show me with your arms. Anybody remember what that graph's going to look like? When we're dividing those things, it's no longer a v, It's going to be 2 straight lines. Okay. Where is the break going to happen on this graph? At 3, because plug in 3. What are you going to get if you plug in 3 here? Like we could do direct substitution. If I took 3 and plugged it in, what am I going to get? 0 over 0. There's a hole at 3. Something funky is happening right here at 3. Take any number bigger than 3 and plug it in. So like 4, right? 4 minus 3 all over 4 minus 3. Absolute value on top. What am I going to get? 1. Okay, plug in 3.5. Plug in 3.1. Plug in 5. Plug in 6. It is this line right here. But at 3, there's a hole. Okay, because we got the same number on top and bottom. I need a number less than 3 as well. Plug in a number less than 3, like 2. If I plugged in 2, it's 2 minus 3 absolute value over 2 minus 3, which would get me -1 on bottom, but what would it get me on top? +1, because you're doing the absolute value of it. So what's my line going to be for that one? -1. Any number, you pick any number you want, it's always going to be negative with an open circle right there. That is the graph. Anytime we get that absolute value of x over x thing like that, you're going to get 2 horizontal lines. Okay, and the break is going to happen wherever this is. Since it says -3, it shifted it to the right 3. So if I know what that graph is, the next question's easy. What is the limit as x approaches 3 going to be for this graph? It's d and e. It's d and e. We are not approaching the same number from the left and the right-hand side. So direct substitution kind of failed for us there. It just get me 0 over 0, and I can't factor that thing. Okay. Instead, I just had to think about what the graph looked like. Kind of make sense on that one? On the next one, the printer didn't do us any good here. That is 0 with a little minus sign. You are finding x approaching 0 from the left. Use your brain, graph it if you need to, but try to figure out what that one's going to be. A little bit different of a graph here. We get that absolute value of x and x in a fraction. So we know it's going to have the 2 horizontal lines. What do you think, where do you think the break's going to be here, since there's nothing added or subtracted with either of them? The break's happening at 0. What is this 2 right here? When we put a number and multiply by it, what's it going to do to my graph? Stretches it. It stretches it. If you don't believe me, take any number and plug in bigger than 1, or bigger than 0, like 1 or 2 or 3. If I plug in 3, it's 2 times, oh, it's 2. And if I plug in 2, it'd be 2, and it'd be 2, and it'd be 2. But at this spot right there, I'm going to have an open circle. There's a hole. Same thing would happen to the left side. So if I plug in any negative number, like 2 times -1 over -1, that is going to get me -2 over a +1. It's -2 down here. Okay, -2, -2, -2. There is that graph here. So what is the limit going to be as x approaches 0 from the left? It is going to be -2, because all I care about is right here as I get closer and closer to 0. It's just understanding the graph. That is nothing more than saying, all right, hey, when I see this, I'm not going to be scared by it. I'm going to know what the graph looks like. Questions there?